So we have a ball of mass 0.1 kg is suspended by a string 30 centimeter long. Okay. Keeping the string taut, the ball describes a horizontal circle of radius 15 centimeter. Calculate the angular speed. So we have something like that. So this is the center, and this is 0.3 meters, 0.1 kg, and then we have, wait, no. Oh, okay. My bad. This is 0.15 meters. Yeah, but the structure is this. So we have a string. Now this is the scenario. This is your vertical thingy, and .15 meters. This is 0.3 meters. So this is a scenario, guys, actual scenario, and we can call this as theta. Okay, so yeah, so this is basically the lengthwise diagram. Now we can draw the free body diagram. So we have a gravitational pull. So this would be of 1 Newton, 0.1 into 10 Newton. I made a point to write in this manner so that I don't mess up the mass value. Sometimes I need the mass value and I mess it up. So we have a string that is pulling somewhere along here. We don't know the angle. So I'll just take this, and we are taking the horizontal in this manner, and this is the angle theta. And this is pulling with certain force. This string is taking care of not only making the object stay in a horizontal plane, but also making it go round and round. So this is providing the required force for wherein you get the centripetal acceleration. So this amount we know, this has to be 1 Newton, same as this. And so from here we can figure out the force along the center. I'll call it as FC. Okay, so this can be the tension. So I'm just calling it as FC, or T horizontal, I can call this also. And this is T vertical. So somehow I have to figure out T horizontal. From here I'll be able to figure out the angular speed. Same funda, just that we have one more dimension to this. Okay, I could have done a bit better job with the diagram, placing the diagram. So let me, better, at least you guys know where it stops and where the other thing starts. Okay guys, now the working. So we'll start off with what? We'll start off with telling that TV, as per Newton's second law, right? We have TV minus 1 is equal to 0, right? Basically should be equal to m into a. Since there's no acceleration along horizontal, we have the following. So we have TV is equal to 1 Newton, right? And then, I mean, for a written exam, you have to show all of this. If not, it's just a matter of directly figuring this out. So we can figure out the theta value. So theta would be how much? Well, for that we have to go to this diagram. So tan or cos theta is 0.5 by 0.3. Theta value, we need theta value. So cos theta is equal to 0.5 by 0.3. So this is theta is equal to half, which is 60 degree, right? So with that in hand, we have to figure out. So this is from figure 1. This is figure 2. This is from figure 1. In theory exam, yes, we need to write all of this in detail. What is that we are getting, where is that we are getting from. I'll figure out TH now. So for that, I'm making use of tan theta, which is opposite. Opposite is TV. This is TH. 60 is root 3. TV below vertical is 1 and TH. So TH is equal to 1 by root 3 Newton. So now we know TH, and then we can figure out omega. So TH is equal to mass times of AC, and this is m times of omega square r. I know that I'm doing a lot of writing over here, but yeah, we need that. 1 by root 3 is equal to mass is how much, guys? Mass is, I forgot, 0.1. Omega square times of radius is 0.15. Yeah. Okay, so this is some weird value, but that is your answer. So let's figure it out. 1 divided by 1.5. No, sorry. Root 3 into 0.015. Okay, so root of 0.025. Root of 0.25. So we have, okay, we have 0.16 radian per second. Did I miss anything? Of course, I have messed up the calculation. It can't be that value. So let's have a look. So what I did was not 1 divided by root 3 times of 0.015. So this is 0.02, actually 6. So that's in the denominator. So the root of this value, actually, my bad. So 1 divided by root of 0.26. Okay, now I got it. Because you can't have something revolving so with that value, 6.2 revolution per second, right? So that would be your answer.